Students, welcome to Excel tuition, and in this video we will go through some MCQs and question answers on the science lesson light, reflection and refraction. So let us start. First, the depth of a coin lying at the bottom of a bucket full of water appears less than its actual depth due to dash. Refraction, reflection, dispersion and deviation, and the correct answer is refraction. A concave mirror forms a virtual erect and enlarged image when the object is placed at C, between P and F, between C and F, and beyond C, and the correct option is between P and F. When a concave mirror is used as a shaving mirror, the face should lie dash at C, within the focal length, between F and C, beyond C, and the correct option is within the focal length. If a concave mirror is to be used to set fire to a piece of paper, the paper is to be placed dash at F of the mirror, at C of the mirror, between P and F of the mirror, and between C and F of the mirror, and the correct option is at F of the mirror. When a dentist uses a concave mirror to see a large image of a tooth, the tooth lies dash at C of the mirror, between C and F of the mirror, at F of the mirror, and between the pole and F of the mirror. And the correct option is between the pole and the F of the mirror. A ray passing through the center of curvature of a concave mirror after reflection dash passes through F, travels parallel to principal axis, passes through P, travels along the same path, and the correct option is travels along the same path. Point E lies on the principal axis of the concave mirror. A ray of light passes through E obliquely to the principal axis and it's reflected by the mirror in the same direction. Therefore, point E dash lies beyond C, lies at C, lies between F and C, and lies at F. And the correct option is lies at C. A convex mirror always forms a dash real inverted and diminished image, real inverted and enlarged image, virtual erect and diminished image, virtual erect and enlarged image. And the correct option is virtual erect and diminished image. A virtual erect and diminished image is always formed by a convex lens and convex mirror, a concave lens and concave mirror, a convex lens and concave mirror, a concave lens and convex mirror, and the correct option is convex lens and convex mirror. The focal length of a concave mirror is 12 cm. Its radius of curvature is 6 cm, 12 cm, 24 cm, and 48 cm, and the correct option is 24 cm. The focal length of the concave mirror is 10 cm. The object placed at a distance of 15 cm from the mirror will form an image dash at F, at C, between F and C, beyond C, and the correct option is beyond C. When a convex lens is used as a magnifying lens, the image formed is dash real inverted and magnified, real erect and magnified, virtual erect and magnified, virtual inverted and magnified, and the correct option is virtual erect and magnified. A convex lens forms a real and diminished image of an object placed at a point B on its principal axis. Therefore, point B dash lies beyond 2F, lies at 2F, lies between F and 2F, lies within the focal length, and the correct option is lies beyond 2F. If the magnification is minus 0.5, the image is dash real inverted and enlarged, virtual erect and magnified, real inverted and diminished, virtual erect and diminished, and the correct option is real inverted and diminished. If the magnification is +3, the image is dash, real inverted and enlarged, virtual erect and enlarged, real inverted and diminished, virtual erect and diminished. And the correct option is virtual erect and enlarged. The power of convex lens is 2 diopters. Therefore, its focal length is dash 2 meter, 4 meter, 0.5 meter and 0.25 meter. So after calculating, we got 0.5 meter, which is the correct answer. The power of a lens is +4 diopters. Therefore, it is a dash. Diverging lens with f is equal to 25 centimeter. Diverging lens with f equal to 0.4 meters. Converging lens with f is equal to 0.4 meter. And converging lens with f is equal to 25 centimeter. And the correct option is converging length with f is equal to 25 centimeters. The speed of light is maximum in dash. Glass, water, air, vacuum. And the correct option is vacuum. When a ray of light travels from a denser to a rarer medium, dash, it bends towards the normal, it bends away from the normal, it travels without bending, it travels along the normal. And the correct option is it bends towards the normal. The refractive index of water is 1.33 and that of kerosene is 1.44. When light travels from kerosene to water, dash, it bends towards the normal, it bends away from the normal, it travels along the normal, it travels perpendicular to the normal. And the correct option is it bends away from the normal. The refractive index of benzene is 1.5. If the speed of a light in air is 3 into 10 raised to 8 meters per second, then the speed of a light in benzene is dash 2 into 10 raised to 8 meter per second, 3 into 10 raised to 8 meter per second, 3.5 into 10 raised to 8 meter per second, and 4.5 into 10 raised to 8 meters per second. And the correct option is 2 into 10 raised to 8 meters per second. If the image of an object formed in a plane mirror is of the same size as the object, the magnification produced is 0, -1, +1, between 0 and +1. And the correct option is +1. Light travels fastest in dash, air, water, vacuum and diamond. And the correct option is vacuum. Now let us go through some short answer type questions and definitions. First, define refraction. Refraction is the phenomenon by which the direction of propagation of the light changes when it travels obliquely from one medium to the another. Center of curvature of spherical mirror. Center of curvature is the center of the sphere of which the spherical mirror is a part. Radius of curvature of the spherical mirror. Radius of curvature is the radius of the sphere of which the spherical mirror is a part. Principal axis of a spherical mirror. It is the imaginary line passing through the pole of the mirror and the center of curvature. Principal focus of concave mirror. Principal focus of concave mirror is a point where parallel rays parallel to the principal axis meet after reflection from the mirror. Principal focus of a convex mirror. Parallel rays parallel to the principal axis after reflection appears to come from a point on a principal axis of the convex mirror. This point is called principal focus of a convex mirror. Principal focus of a convex lens. It is the point where the rays parallel to the principal axis converge or meet after refraction through the lens. Optical center of a lens. Central point of a lens. Principal focus of concave lens. Principal focus of a lens. The point from where rays parallel to the principal axis appear to diverge after refraction through the lens. Magnification. It is the ratio of the height of the image to the height of the object. Power of lens. Power of a lens is the reciprocal of its focal length. Power of one diopter of a lens. The power of a lens is one diopter when its focal length is 1 meter. Refractive index. Refractive index is the ratio of the sine of the angle of incidence to the sine of the angle of the refraction. State the laws of reflection of light. The laws of reflection of light are: first, the angle of incidence is equal to the angle of reflection. Second law is the incident ray, the normal and the reflecting surface at the point of incidence and the reflected ray all lies in the same plane. State the law of refraction. First, the incident ray, the refracted ray and the normal to the interference of the two transparent media at the point of incidence all lie in the same plane. Second law, the ratio of sine of angle of incidence to the sine of angle of refraction is constant for a light of a given color and for a given pair of media. State Snell's law of refraction of light. When light travels from one medium to another, the ratio of the sine of the angle of incidence to the sine of the angle of refraction is constant. State the nature of the image formed by the plane mirror. The image formed by a plane mirror is always virtual and erect. The size of the image is equal to the size of the object. Why is the power of convex lens positive and that of a concave lens negative? Power is the reciprocal of the focal length of a lens. The focal length of a convex lens is positive and that of the concave lens is negative. Therefore, a convex lens has positive power and a concave lens has negative power. Give two differences between concave mirror and convex mirrors. Concave mirror and convex mirrors. The reflecting surface is curved inwards. The reflecting surface is curved outwards. The center of curvature lies in front of the reflecting surface. The center of curvature lies behind the reflecting surface. See, they converge the rays, they diverge the rays. Real image and virtual images. Real images are inverted, virtual images are erect. Magnification is negative according to the new Cartesian sign convention. Magnification is positive according to the new Cartesian sign convention. A convex lens and a concave lens. Convex lens is thick at the center and thin at the edges. Concave lens is thin at the center and thick at the edges. It is a converging lens. It is a diverging lens. A pencil partly immersed in water appears to be displaced at the interface of air and water. Why? As the light from the immersed portion of the pencil comes into air, there is a change in direction due to refraction. So the rays of the light appears to come from a point different from that of the actual point. State the similarities between concave mirror and convex lens. A concave mirror and a convex lens both converge rays of light. The nature of the image formed by an object at similar location in both is the same.